Hello children, today I am here to teach you chapter 26 in your textbook, that's construction of triangles. So when you see the word construction, what are the tools you can use? The pair of compasses and the straight edge, the ruler. So in this lesson, we are identifying that the sum of the lengths of any two sides of a triangle is greater than the length of the remaining side. And also we are constructing triangle when the lengths of all the sides are given. So in this lesson, mainly focus on constructing geometrical figures. So only use pair of compass and straight edge. So we'll first construct a line segment. So how we construct a line segment? So we can first draw a line. Any length you can take here and then take the ruler and the compass. Now you can measure the length, 8.4 centimeters. So you take 8.4 centimeter length . 8.4. Need to take it correctly. So here to here, and then what you do, you keep on the line and just mark the first arc here. So mark it here. Then take the compass there to that point and you can draw the other arc. Now we can see the length is 8.4 and the 2 points are A and B. So this is 8.4 centimeters and this is A and this is B. So this is a line segment. Construct CD equals 10.5 centimeter. Again, you have to do the same thing. What's the first step? Draw any line and then take the compass and take, what's the length? 10.5. 10.5 length. 10.5 here to here, and then you can mark the 2 points. You can mark 1 point here and another point there. So what's the distance? 10.5 centimeters. And then you can label, this is C and D. So this is CD line segment. Do the same thing. Construct EF equals 12.8 centimeter line. So you can draw another line and then you take the compass and measure 12.8 centimeter. 12.8 centimeter. So this should be more. 12.8. 12.8 centimeters. So you keep on top of the line and then you can mark the points. Here, I'll take it here and see. Yeah, it's possible. So you can mark the arc here and then keep on top of the other point and draw the other arc. So this is EF line segment with 12.8 centimeters. Constructing equilateral triangle. So what are the properties of an equilateral triangle? So all sides are equal and one angle is 60 degrees. So we are using the property all lengths are equal when you are constructing equilateral triangle. So what's the length given there? So we need to construct 12.5 centimeter side length equilateral triangle. So for that again, first we'll draw the line segment with 12.5 centimeter length. So take the compass and the ruler and measure 12.5 centimeter length. So 12.5. So you can first keep on top of this line and you can mark the arc. And also you can mark another point somewhere here in between, because this distance and this distance all are equal. So you can do at once somewhere here in the middle, like you can draw an arc. Don't change the length. Now you can keep the same length here and you can draw two arcs here as well as on the line. Now we can see we have 3 points. All the distances are equal. Here to here 12.5, here to here 12.5, here to here also 12.5. So we can label this point is A, this point is B, and this point is C. Now take the ruler and connect all 3 points. So that's the equilateral triangle. Now connect all the points here to here, here to here. So this is an equilateral triangle with side length 12.5. Construct PQR equilateral triangle with side length 9.7. You have to do the same thing, but now the side length is 9.7. So take any length and take the compass and measure 9.7 centimeter length. 9.7. Then what you do, you take the compass and keep on the line and you can mark 2 arcs. One on the line and in between, somewhere here in between, you are getting the other point. So take the same distance, don't change it. You take the same distance here and draw arc here as well as on the line. Now you can connect the points here to here, here to here. So what's the length? 9.7 centimeter length. So what's the triangle? PQR. So we can label the triangle PQR and side lengths are, all side lengths are equal. Constructing regular hexagon. So what's a regular hexagon? Hexagon means 6-sided polygon. And regular means all sides are equal. And one angle, can you remember one angle? We can find out that's 120. But we are not using the angles, we are just using lengths. So how can we draw a hexagon? We can use a circle for that. So first thing you have to do, you can measure the length 8.8 centimeters and then you can draw a circle with radius equal to that. So here 8.8. 8.8 is here. So you can draw the circle now. So the radius is now 8.8 centimeters. So we'll draw a circle. So you can draw the circle with radius 8.8. Then what you do? You take any point on the circle, keep the compass there and you can mark arcs with the same length. You can't change the length. So you can keep at any point and draw arcs. One here and keep the compass here and draw the other arc. So how many arcs you get around the circle? You get 6 arcs because hexagon means 6-sided polygon. So you mark all the sides like this. So 6 arcs you have to draw. This is the last one. So we have 6 arcs around the circle. Now you can connect the points with the ruler. So here this point to this point. Here to here. And here to here. Here to here. And other points as well. Now you can see you get a hexagon. That's a regular hexagon. All these lengths are equal. And that's 8.8 centimeters. So we can label A, B, C, D, E, F. When you are labeling, make sure that you write down the letters either clockwise or anti-clockwise way. You can't put A, B, C, D here and there. So if I take anti-clockwise, I can label A, B. This is C, D, E, F. So that's the A, B, C, D, E, F regular hexagon. Construct PQRSTU regular hexagon with side length 6.3 now. So what you have to do, you take the compass and measure 6.3 centimeter length. That's the radius of the circle. 6.3. 6.3 centimeter. So you can draw a circle. And then with the same length, you can draw 6 arcs around a circle. 1, 2, 3, 4, 5, and another point. 6. Now we have all 6 points. So you can just connect the points with the ruler. Take the ruler and connect all these points. Connect all these points. So that's the regular hexagon. You can label it P, Q, R, S, T, U. And all sides are equal. And what's the length? 6.3 centimeters. Constructing scaling triangles. So what are scaling triangles? So scaling triangles means a triangle with all lengths are different. So you can get different lengths. So this can be a scaling triangle. So how can we identify whether we can draw a triangle? So take, this is 8 centimeters and this is 9 centimeters and this is 10 centimeters. How we identify whether we can draw this? We can construct this. So we can check with the two lengths. Now think about when you take this length, 10 centimeter length, and if you keep this length and this length, what can you say? So that's more than 10. So when you keep 8 here, 9 here, it overlaps. So when you add the two, 8 plus 9, 17 centimeters. So that's bigger than 10 centimeters. If it's equal, think about this is 5 and this is 5 and this is 10. So what do you think? Can we make a triangle like this? So 5, so think about 5, 5. So exactly equal to 10. When you add these two, you are getting exactly 10. So that means you are not getting a triangle. That's a straight line. So these two lengths, adjacent lengths, should be bigger than the other length. So when you are drawing a triangle, scaling triangle, make sure when you add the two sides, you need to get the other side less than that. So we'll take this one, 8 plus 9, that's 17. That's greater than 10. When you take these two, 10 plus 9, that's 19, greater than 8. Then when you take 10 and 8, that's 18, that's greater than 9. So all these pairs satisfy this equation. So the two sides, the sum of two sides is bigger than the other length. Then only we can draw the triangle. But in this case, you can't. 5 plus 5 is equal to 10. So you can't draw a triangle here. Cannot draw a triangle. So now we'll just try it whether we can draw a triangle. So take 10 centimeter length and do. So take 10 centimeter length. So we need the ruler and the compass. So we'll check. We want to check whether it's true. 10 centimeter length, and we'll just mark it here. I'll put a tick here and mark it here. Now take 5 centimeter length. Take 5 centimeter length and we'll try to draw the other point. So now we can draw the arc here and same length here. So we'll try to draw the other arc and see whether it's intersecting. Can you see? You can't find an intersecting point. Intersecting point is here. You can't find an intersecting point. Intersecting point actually on the line because that's equal. So here intersects here on the line. So that means you can't create a triangle. So when you want to construct a scaling triangle or whatever triangle, so what's the condition? You have to check before you construct, check whether the sum of two lengths is greater than the remaining side. Construct ABC triangle with AB 9 centimeters. AB 9 centimeters, BC 8 centimeters and CA 7 centimeters. So what's the first step? You can check whether you can construct it. At any two sides, 9 plus 7, 16. That's greater than 8. Then take the other two sides, 9 plus 8, 17. That's greater than 7. Then other two sides, 8 plus 7, that's 15. That's greater than 9. So this is true. So that means you can construct the scaling triangle. So we'll construct now. So that means you can first draw any length and take the compass and the ruler. What's the largest one? 9. So we'll take 9 to this side, or we'll draw the same thing. So 8 centimeter on this line. You measure 8 centimeter length and you can draw the two arcs here and here. So now this is 8 centimeter length. Now the other side is not 8, 7 centimeters. So we have to change the length now to 7 centimeters. 7 centimeters is here. Now from C, so you have to keep here and draw an arc in the middle area, somewhere here. Now the other side, that's 9 centimeters. So 9 centimeter length you have to take from the compass. Centimeter here, and you can draw the other arc from this point. The intersecting point becomes the other point. So here this is the intersecting point, that's A. Now we can connect the 3 points. Here to here, here to here. So that's the scalene triangle. All lengths are not equal. So 9 centimeter here, 8 centimeter and 7 centimeter here. So that's A, B, C scalene triangle. Construct PQR triangle with PQ 10 and QR 11 and PR 9. So we'll mark it PQ 10 centimeters, QR 11 centimeters and PR 9 centimeters. Can we construct? So first of all you have to check 10 plus 9, 19. That's greater than 11. Then 10 plus 11. What you get? 21. That's greater than 9. Then 9 plus 11. That's 20. That's greater than 10. So this is true. So you can construct the scaling triangle. So we'll construct that. So what you do? Take the ruler and first draw any line. and take the compass and the ruler and measure the length. So 11 centimeters. So we have to take 11 centimeter length. So 11 centimeters is here. So first we'll mark that on this line. So you can draw the arc here and again the arc onto the other side. So this is 11 centimeters. Now 9 centimeters to the other side. So we'll take 9 centimeters and draw the arc from here to this side. So we'll draw it somewhere here. And then you need 10 centimeter length. So take the compass and now you can measure 10 centimeter length. 10 centimeter length and draw the other arc here. Now we have all 3 points P, Q, R. So this is P, this is Q, and this is R. 11 centimeters, here 10 centimeters and 9 centimeters. We'll connect with the ruler here to here, here to here. So that's a scalene triangle PQR. Can we create a triangle with 3 equal sticks with any length? Now you know that. Can we do that? So you can write down not always. Give reason for cannot making the triangle here. So we can say one equal stick is not long enough to make a triangle. So we can see this length is bigger, but here this one needs to be longer than that. So we can write one equal stick is not lengthy to complete the triangle. Now they ask, how can we create a triangle then? So you need to consider the lengths. Sum of 2 lengths needs to be more than the remaining side length. Then only we can create a triangle. Construct ABC triangle with AB 7 centimeters, AC 8 centimeters and BC 18 centimeters. So you have to check before you start to construct, you have to check. We'll check whether we can construct 8 plus 7, 15. Now what happens? When you add these two, it's less than 18. So we can't construct a triangle here. So we can say cannot construct this triangle. So 8 plus 7, 15. 15 is not more than 18. It's less. Given that 3 centimeter, 4 centimeter, 5 centimeter, 7, 9 lengths equals 6. Can you make triangles using 3 lengths? So you need to check with 3 lengths. So we'll first check 3, 4, 5. 3 and 4, 7. That's greater than 5. So next one, 4 plus 5, that's 9. That's greater than 3. Then 3 plus 5, that's 8. That's greater than 4. So we can make a triangle there. Now we'll take another 3. 3, 4, 9 now. We'll check with 3, 4, 9. 3 plus 4, 7. 7 is less than 9. So if one side is not satisfying, that means you can't construct a triangle. So you don't need to check the other two. So from this point, you can say cannot construct a triangle there. Now check with 3, 7, 9. 3 plus 7, 10. 10 is greater than 9. 3 plus 9, 12. 12 greater than 7. 7 plus 9, 16. 16 is greater than 3. So you can draw the triangle. Can construct the triangle. Another 3 measurements, 4, 5, 7, we'll check. 4 plus 5, 9. 9 is greater than 7. 5 plus 7, 12. 12 is greater than 4. 4 plus 7, 11 is greater than 5. So that means all satisfy, can construct a triangle. So the sum of the lengths of any two sides of a triangle is greater than the length of the remaining side to construct a triangle. Construct a triangle PQR with PQ 7. This is 7. QR 10 and PR 18. Can we do that? We'll check. 10 plus 7, that's 17. 17 is less than 18. So you cannot construct the triangle. Construct an isosceles triangle with AB 10, BC 11 and CA 10. Isosceles means two lengths are equal. So can we do that? We'll check. 10 plus 10 greater than 11. And if you take 10 plus 11, that's 21 is greater than 10. So that's true. You can construct the triangle. So we'll try to construct it. So what you have to do, you take the ruler and draw any length and take the compass and the ruler. Now we need to measure first 11 centimeters. Measure 11 centimeters. Here. Now keep on top of this line and mark the two arcs here, and again other side you can construct the arc here. So 2 arcs there, that's BC. Now you need to take 10 centimeter length. 10 centimeter length. And now you keep on top of this point and you can draw an arc in the middle, somewhere here, and take the compass here and same length. AB and AC same length, so you can mark the other arc here. Now we have 3 points we can connect with the ruler. Connect this point. So we can mark ABC. A, B, C. And these two lengths are equal, 10 centimeter, 10 centimeter, and this is 11 centimeters. Now we have to measure B and C angles. So what we do, we can take the protractor and measure. So B angle, you keep the protractor here and measure the B angle first, here to here. So I get here to here 55. And here also I get this side 130. 125 means this way, 125 means this side is 55. 10, 20, 30, 40, 50, 55. So both angles are the same. So we can write B angle is equal to C angle, that's 55 degrees. So we know that it's a property of an isosceles triangle. If these two lengths are equal, these two angles also equal. Now we'll look at review exercise. Construct the straight line segment AB of length 7.9. So take the ruler and take any length, and with the help of the compass, you can measure the length. That's 7.9 centimeters. And you can mark that on the line. Here and on the other side, you can mark the other point. So this is the line segment AB with 7.9 centimeters. Construct an equilateral triangle of side length 5.4 centimeters. So how we construct an equilateral triangle? So we first draw the line segment and measure 5.4 length. 5.4 length. And you keep on top of this line and you can mark 1 point here, 1 point here, then the other two lengths also equal. So you take the same distance, draw an arc in the middle and keep on top of the other point and arc here. So the intersecting point is the other point. Take the ruler and connect these points here and here to here. So what's the triangle? So you don't need to label, but all sides are equal. That's 5.4 centimeters. Construct a circle of radius 4 centimeter and center O. So we'll take the ruler and the compass. Construction means always compass and the ruler. 4 centimeters now. 4 centimeter radius. And we'll draw the circle. We'll draw the circle. And it says center O. Construct the regular hexagon ABCDEF of side length 4 centimeters such that its vertices lie on the above constructed circle. So how we construct a hexagon? So you take any point on the circle and you draw arcs around the circle. So you get 6 arcs like that. And don't change the length, equal length. This length should be equal to the radius. Now we have 6 points. Use the ruler and connect. Now you get the hexagon ABCDEF. We'll label ABCDEF. That's the hexagon with side length 4. So all these lengths are 4 centimeters. Construct a regular hexagon of side length 5 centimeter. You have to do the same thing. Now the radius is 5. Do that now. So take the length 5 centimeter. First you have to draw the circle. And then take any point and draw the 6 arcs around the circle with the same distance. So you get 6 arcs because hexagon is 6-sided polygon. Now you can connect all the points with the ruler. So this is the hexagon with side length 5 centimeters. Exercise 26.1. Choose the triples from following groups that can be the lengths of the sides of a triangle. For each triple that was selected, write the reason for your choice. For the triples that were not selected, write the reason for not selecting them. So basically, we have to check whether we can construct the triangles. So we'll take the first one, 5, 6, 7. So we'll take 2 lengths, 5 and 6, 11. That's greater than 7. 5 plus 7, 12. 12 is greater than 6. Then 6 plus 7, 13. That's greater than 5. So this is true and can draw a triangle. Why? The sum of 2 lengths is greater than the third length. So you can write same reason, sum of 2 lengths is greater than the third length. What about this one? 4, 4, 4. We'll check 4 plus 4. you get that's greater than 4. So same thing happens when you take two pairs, same thing happens. So true. So this is an equilateral triangle. So can construct an equilateral triangle. What is this triangle? 5, 6, 7. It's a scalene. This is a scalene triangle. 4, 4, 8. We'll check 4 plus 4. That's equals to 8. Not greater than 8. So cannot draw a triangle. What about this one? 3, 3. 6. 6 is less than 7. So cannot draw a triangle. Cannot draw a triangle. 5, 5, 8. 5 plus 5, that's 10, greater than 8. 5 plus 8, 13 is greater than 5. So you can, same pair again. So can draw a triangle. Now here, what type of triangle? Two sides are equal. So you can write, can draw an isosceles triangle. What about this one? 6, 4, 10. 6 plus 4, that's 10. That's equal to 10. That's equal to the third side. So cannot draw a triangle. Exercise 26.2. Construct two equilateral triangles, one of side length 4 centimeters and the other of side length 5.7 centimeters. Measure and write down the magnitudes of the angles of the two triangles. So you are asked to construct two equilateral triangles. So we'll take a length here, again here another length, because we have to construct two triangles. We can take 5.7 centimeter first. 5.7. We are here. Now we can take the length 5.7 and draw arc here and arc in the middle. And here, keep it on top of this point and draw the two arcs. Arc here and arc here. Now we have the three sides. We can connect the 3 points. So this is the equilateral triangle with side length 5.7. And now we'll construct the triangle with side length 4 centimeters. You take the measurement now 4 centimeter length. 4 centimeter length, and you can first mark this point and a point in the middle. And again keep on top of this point and draw this arc and the other one. Now we have the 3 points and you can connect. Here to here, here to here. What's that triangle? Side length 4 centimeters. Now we'll measure the angles and see. So this is an equilateral triangle. What's the angle? Each angle should be 60 degrees. We are checking whether it's true. So you can see here 60 degrees. This one. Here, this side 120 means this is also 60 degrees. And you can check from this side as well. That's also 60 degrees. So we'll take the other triangle and see. So measure the angle. So here 60 degree here, and keep on top of the other point and see this side 120 means that's 60 degrees, and when you rotate and find out the other angle here, that's also 60 degrees. So all angles are 60 degrees. So measure and write down the magnitudes of the angles. So I can write 60 here, 60, 60. And also in this triangle also 60, 60, and here 60. Construct triangles with the given side lengths by using a pair of compasses and a ruler. Show that the sum of the angles of each of the triangles you constructed is equal to 180 by measuring them. Categorize the triangles according to the largest angle. So we'll check first whether we can construct it. So we'll take the first one here. 6, 8, 10. 6 plus 8, 14, that's greater than 10. 6 plus 10, 16 is greater than 8. Then what's the third one? 10 plus 8, that's greater than 18, greater than 6. So can construct a triangle. So we'll construct 6, 8, 10. So we'll take the longest side first. So you can take the ruler and take any line segment and take the compass and measure 10 centimeters first. You take that length and keep on top of the line and draw the arcs. You need to mark the 2 arcs. So that's 10. What's the next length? 8 centimeters. Now take the compass and measure 8 centimeters now. From here, 8 centimeters. And you can mark the point to this side. So this is 8. So you can mark the arc somewhere there. Now we have to mark the 6 centimeter length. Now the 6 centimeter length. So you have to mark. So this is the distance, 6 centimeters, and you have to keep it on top of this arc and mark the arc. Now intersecting point is the vertex point of a triangle. Now you can connect here to here, here to here. Now what they ask? They ask to measure angles. So we need to measure angles now. 10, 8, 6. And see, the sum is 180 degrees. So we'll take the protractor for that. To measure the angles, you need a protractor. So we'll measure this angle first. This is 35. This side. This side I get 10, 20, 30, 40, 55. 55, 35. So we'll mark it. This is 35. This is 55. And we'll see what's this angle. We'll measure this angle and see what's the angle. Here to here, 90 degrees. So 90 degrees is this angle. Now we'll add and see. This is 90 degrees. Now we'll add and see whether it's correct. 90, 35 and 55. You get 180 degrees. So this is true. And what type of triangle is this? Now 190 degree angle is there. So this is a right angled triangle. Right angled triangle. Take the next one. 4.5, 6 and 7.5. So we'll add first to 4.5 plus 6. 10.5, that's greater than 7.5. 4.5 and 7.5. 12. That's also greater than 6. Then 6 with 7.5. 13.5, that's greater than 4.5. So we can construct a triangle. Can construct a triangle. So we'll do that now. So we have to take line segment. And using the ruler and the compass, we can measure lengths. We can measure lengths. So we'll take 7.5 first. That's the largest side. 7.5. That's this length. So we can first construct there. Here and the point, other point to this side. Here. That's 7.5. Now what's the next length? 6. So we'll take the compass and measure 6 centimeters. 6 centimeter length here. So we can keep on one of the point and draw the arc. 6 centimeters. And the other side 4.5 centimeters. 4.5 centimeter length. So we have to measure it again. 4.5 centimeters. So here And you can draw the other arc there. So this one. Now we have 3 points. Connect the 3 points and make the triangle. And we can mark this is 7.5, this is 6, and this is 4.5 centimeters. Now we'll measure the angles and see. For that you use the protractor. What's the angle here? 40 degrees. What's the angle here? We get from this side 10, 20, 30, 40, 50, 54, 40 and 54. Now we'll measure the other angle. You have to measure it properly here. What's the angle there? So you get from here 86. From this side, that's 86. This is 86. We'll see whether it's true now. Add the angles and see 40, 54 and 86. 10 and here 9 and 9, 18. So that's add up to 180. And what type of triangle is this? This is scalene triangle. And here we have to look at the angle and see. All the angles are less than 90 degrees. So this is acute angled triangle. If you are looking at lengths, that's a scalene triangle. Now this one, 5, 5, 4. Can we draw? 5 plus 5, 10. That's greater than 4. And 5 plus 4, 9 greater than 5. So can draw a triangle. And we'll draw it now. Now you know how to draw a triangle. Take any length and using the compass and the ruler, you can measure the lengths. So we'll take first the 5 centimeter length. 5 centimeter length. Mark here as well as another point because two lengths are 5 centimeters. So I can mark an arc somewhere here. Now we'll take 4 centimeters here again. Keep it here and mark 5 centimeter here as well because two 5 centimeter length. And now we'll take 4 centimeter length and mark it here. Keep on top of this point and mark the arc. Now we have the triangle. Connect all 3 points. So you get this triangle and here we can mark it. This is 5 centimeter, 5 centimeter. And these two lengths are equal. This is 4 centimeter. Now we'll measure the angles. Using the protractor, we can measure the angle. So what's this angle? So you can keep it properly. and measure the angle. So I see that's 50 degrees. This angle is 50. What about this one? This one, I get here 10, 20, 30, 40, 50, 60, 65. 65 here. 50, 65. So what's the other angle? We'll measure and see the other angle. I get 65. So 65 for this angle as well. Now we'll check it. 65, 65 and 50. 10 and then you get 666, that's 80. So the sum is 180, that's true, and two angles are equal and two sides are equal. What type of triangle? This is an isosceles. Isosceles triangle. So we completed all theory related to constructing triangles. So when we are constructing a straight line segment of length equal to the length of one of the sides of the triangle, constructing an arc of length equal to the length of another side of the triangle by placing the point of pair of compasses at one end point of the above straight line segment. So this is how you can construct. So what's the main thing when you are constructing a triangle? The sum of the lengths of any two sides of a triangle is greater than the length of the remaining side. So construction is an important lesson. So we are continuing this lesson in grade 9, 10, 11 as well.